Hi, so we've been doing some work on flat wind generators, and it was pointed out to me that number 5 that I did in the previous video on flat wind generators could be found by just looking in a car blower. Now, I've got a car that actually is a scrap car and I pull bits off, so let's go and get the blower out of it. So I have this old Nissan Micra in the car park, and basically whenever I want to do something I come out and pull bits off it. Now I wanted this thing, which is, there we go, it's the blower. The blower motor was pointed out to me, as well as the squirrel cage, as being an interesting possibility. So I thought, oh, okay, I'll go and pull it out. That meant taking off the dashboard. No, it wasn't too much of a problem. Let me give you a view of that. There we go. Wasn't too much of a problem. There's 3 bolts and half a dozen screws. Undid those, pulled them off, undid all the clips, and there's the blower motor with its AC unit. And that's the bit that we're going to take inside and have a better look at. Okay, so I bought the whole cluster inside, and there's the actual unit I'm after. That's clearly some kind of AC, so I'm going to take this unit apart, see what we've got in there. I'm lucky, obviously, because I don't have to put this back. If I had to put this back, I think I'd think twice, because that was a bit of a pain to get it out. But hey-ho, it's a scrap car. Okay, so the main things out of this big old lump of black plastic housing with this thing, which is obviously a radiator, so it's part of the heat exchanger. I mean, it's a beautiful piece of kit, so I'm going to keep that. Got to be able to do something with that. Now, clearly, these went to water inlets and outlets, so there'll be a pump somewhere. Trace them back, we can get a pump. This was a piece of cake to remove. This is the blower motor. It's a pancake motor, and it has this squirrel cage rotor attached to it. I only had 3 fixing points, dead easy. I kept the back piece, incidentally, in case we want to put that out, because obviously that'll make a nice cover for it. So those are the 2 main bits. Let's clean up a little bit. So there it is. It is indeed exactly what we're looking for. Squirrel cage, a conic section in the centre, and a bit of a motor. If we pull that off, then that's actually quite a nice motor. It's quite heavy, takes a fair bit to turn it, so I think there's going to be no chance that that's going to turn that. It's about 18 watts when it's on no load, so it's 12 volts, draws about 1.5 amps. Probably 25 watts when under load, and anything more than that is going to burn the motor out. But a lovely motor, you've got to think, I've got to use that for something at some time or other. But like I said, this is tiny. It has no chance at all of driving that around. If you wanted to drive that around, you have to make a bigger one of these, or we'd have to put some blades on it, something like that. But we're investigating flat wind generators. Now, there's a reason that I'm fascinated by such things. I live in the UK, and it's my understanding that if you want to put something up that goes beyond the roof line, you need planning permission. So you can buy a wind generator, you can't put it up. You have to talk to the local council and get planning permission to put a wind generator up. That strikes me as a pain in the neck. If we attach things to the walls, we don't need any planning permission at all, particularly if we attach it around the back of the house where it can't be seen from the road. You can just do that, and that really attracts me, because I don't really like asking for permission to do things. So if we're going to use this, and just to see how this works, what I'm going to do is stick it to that thing that we made in the previous video. Here we've just got a little motor, we've got a flywheel glued to it, and we're going to stick that onto there like that. Handily enough, it's about the same size as a CD, which is pretty cool. Now, lots of comments really, and some of the comments people were saying was that won't work on a flat wall because of changes, no change in pressure, etc, etc. And I thought, well, that's actually fair enough. So let's stick that on a great big bit of board, so we've effectively got a flat wall. The other main comment I got was that if you're using something like this, you're blowing wind at it at 40 miles per hour. And yeah, I suppose I am really. They're about 20 to 40 miles an hour, depending on the speed and the hairdryer that you're using. It's not a massive volume of air, but it is quick. And I thought, yeah, okay, I've got a fan, and we'll just stick a fan in front of a big board with that on it. And it's the best we can do because there is no wind. Now, a fan actually creates a corkscrew of air. So we still don't really know what it would be like if we put it outside, because the outside obviously is a distributed stream with quite a lot of random variation. A fan creates a corkscrew which is fairly even and in one direction. So we're not really finding out exactly how it's going to work, but we are getting some information on what we need to look at in order to make it work. So that's what I plan on doing, is sticking that on a big piece of board, popping that in front of it, and turning on a fan. Now, there was another comment which I really liked, and I'm actually, there it is. I really liked, and it was that when that wind hits this area, then it's actually quite a small area, which is fair enough. When you think about a blade, the swept area of a blade can be really quite large, a metre and a half, even for a small device. And here we've got about 20 centimetres. Seems unfair. So stick a cone in front of it. I happen to have this metal cone. This metal cone is meant for slump testing concrete, but if we put a cone on it, what we're doing is increasing the area that the wind is hitting, and so that should make it better, if you like. So we'll try that as well. So we'll try it with and without on a flat bit of board. Let's set that up and have a look at it. Okay, so following people's suggestions and comments on the previous video, I've rigged this up. What I've got here is a large fan. It's a large volume fan, so it's meant for moving large volumes of air around a room to keep you cool. So about here, actually, the wind isn't in fact particularly strong, and you can see that our rotor isn't turning, which you might think is a bit disappointing. But I've also put the thing on a big flat board to kind of simulate what it would be like were it nailed to the side of a house. Now, one suggestion that I thought was awesome was put a cone in front of it. So I've got a cone here. It's actually a slump cone for testing cement. And if we pop that slump cone in front of it, there we go. So we're capturing more volume of air, and it's working a treat. The other thing to do is to increase that wind speed. So if we move this closer, that, if you like, represents an increase in wind speed. I really prefer that. I think that's very awesome, actually. Now, other comments have been, it's under no load, so let's just short circuit it, which is effectively a load. If we short circuit it, there we go, still turning. So we know it'll turn under a load. Actually, I find it quite fascinating. Okay, I thought that was pretty cool, actually. Now, like I say, if we want to run that one, we've got to make a bigger disc. And to be honest, I might make a bigger disc because it is giving pretty nice results. So why not? Let's have a go and see what happens with it. But I did want to talk about a couple of other things that have come up in the comments, actually. And it's about what's best for the job. So people will say things like, these vertical ones, they're rubbish, only the horizontal ones are any good. They'll say there's a fundamental flaw to your concept, so they'll just be, it can't possibly work, how can you waste your time on that? And those kind of comments really, I mean, they're fair enough as far as they go, but they don't really look at the whole concept. I mean, we're looking at wind generation, and for wind generation it's really about what's appropriate to the job. So for example, vertical wind generators are just brilliant if you want to stick them on top of something like a lamppost or a building where you couldn't get a bladed wind turbine for lots of reasons. And sure, maybe bladed wind turbines are more efficient, but they're certainly not good for that particular job. So there are things where you have to pay attention to the situation in which you're going to look at something. And it's not only about the geographical situation. Some things cost more. These vertical wind turbines, particularly ones that we're scavenging from scrap, are just next to nothing. So the cost per kilowatt hour of generation is going to be minute. So if you don't have much money to pay 3,000 to 5,000 for your own wind turbine from B&Q, then make one. And if you're not having much skill in handling machinery, then cobble together scrap. One of the good things about these micro turbines is that you really don't need a massive amount of equipment or heavy-duty equipment to be able to do this. You don't need to be able to weld, you don't need to lathe, you're not managing 1-inch bolts or anything like that. These are tiny little things you can do with screwdrivers. Just do a few of them. Add them together and you're going to get some generation. If you source your bits from nothing, that generation is going to cost you very little. So there's an appropriateness of the cost. Then there's an appropriateness of the installation. Like I say, I live here in the UK. In the UK, we can't just stick a turbine up, but we could put these on our walls. So there's a whole load of considerations to think about when you're talking about whether something is the best for a job or not, or whether it's efficient. I mean, efficient in what terms? I mean, if we're talking about cost efficiency, then collecting things from scrap is the most cost effective you can get, so it's certainly very efficient in those terms. So what terms are you talking about when you're talking about efficiency? I think the message here really is, rather than just say, oh no, it can't because, try to have a broader mind. Think about the other possibilities that people may be interested in, rather than just the thing that you're interested in. And it might lead you to new invention and new thought. I mean, at this stage, to be honest, I have no idea whether this is going to work or not. I really don't. But it is fun to investigate it. We are getting some interesting results, and it's certainly worth putting a little bit more effort in to make a bigger one that maybe will drive this. I mean, I'm thinking something about that big, and then maybe a cone on it about that big, and we'll see whether we can drive this motor or not and get this to generate some serious output. Why not? It'll be a bit of fun. On these ones, well, this is just scrap I've cobbled together, so why not? I mean, you know, even if it produces a few microamps, those microamps have been free, or at least they have been sufficient, because the only cost here is my work, and all the rest of it is scrap. I'm guessing that if we put a couple of these up, we could certainly charge our phone, run a radio, a few more, probably run your telly or some lights or something like that. I don't really know. But it's certainly worth looking at, I think. And I always think things are worth looking at. They're worth a think about at least. Anyway, I thought I would share that with you because I thought it was a fascinating thing. And thank you very much for the guys who suggested that I took this out and had a look at it. And I hope you enjoyed the video. I hope it sparked some interest. I hope it got your creative juices flowing. Thank you very much for watching.